I thought class started at 4. Sorry. No? Is that at 4?
I think so. It's a 4, right?
Yeah.
Yeah. Raise your hand if you think class starts at 4.
Although I did think it was.
You can sit anywhere. It ends at 5. It ends at 5, but not today. I know. That's okay. What's that? We'll talk about that. Okay, yeah, bye.
Okay, that's it.
Yeah. You want the snacks that was there? Even the sour gummy fillings are really sour. Really can't.
I kind of want one to be big.
Okay,
Yeah.
I didn't warn you. They're like surprisingly sour. They're not like a warhead, but they're not.
Oh,
good.
okay, that's fine. Those, yeah, those.
Yeah, warheads are fire, but this is not. You want a jelly bean to taste good? This does not taste good. Oh, okay.
Oh, jelly beans taste good.
Okay, we're missing 4 units.
Oh, it's not. Yeah.
That's great.
That's what it is. I walked in here, you looked all upset. I was like, oh.
No, I gotta get like 30 minutes.
Thanks up for that nasty chocolate you gave me.
Yeah, these are also chocolate slices. Orange flavor.
It's pretty good. I want to try it. It's pretty good.
So far it's 1 to 1.
It's like this Richfield.
2 to 1.
It's really good, actually.
Oh, all right.
My favorite food. It's like biting into one of those the Tootsie Pops.
Definitely not. Yeah. Did Bob enjoy it?
Yeah, I'm gonna make sure no one's in 133. I'll be right back, and then we'll start.
They're good. Would you like those? Yeah.
Listen to. Hey, welcome to Intro After for Scientists. Down right room. So it might be listed incorrectly. I also thought that the lab was on Wednesday. So thanks, Toby, for pointing that out. So today's lab, we're not going to go till 8:15 because I didn't prepare for a lab. So instead, we have an open house at the observatory, which you're welcome to go to. And we can do the peak sky observatory. So believe you're going to have the moon. Okay. We'll talk about the whole class in a little bit. Any questions before we get started? Okay. What's this?
Solar system.
Solar system. Good. What do you see?
Planets.
Planets. Good. Only planets? Star planets. What? Dwarf planets? Where? Here? Okay, well, the ones that say dwarf planets. Good. Anything else? The sun. Good. And Ceres, yeah, that's part of the dwarf planets. We got these little boys here. Stronkers. Smalls. Where are we?
Small. Third away.
Third away. And that planet's called Okay. All right, we're good. So let's we're gonna come back to this in a few seconds. Let me introduce myself, and then I'll introduce all of you. Well, I went to undergrad at Santa Cruz. I got my PhD in Boulder, and then I did a couple years at the Goddard Space Flight Center. So I studied the Martian atmosphere. This on the left-hand side is the Maven mission. It's one of the two spacecraft that I used to study the upper atmosphere of Mars. So like 78 kilometers and above. I'm here now. Currently, good job, President. We're all here, which is pretty surprising. Okay. And I'm a scientific member on both of these missions. I go by he, his pronouns, and my office is down the hall. We'll talk about communication as a whole when we talk about the syllabus. Questions about me? Maybe just personal questions, science questions, and how are you doing? I'm doing great. I got Andy. Yeah, teach again. Perfect. Okay, so now we're gonna go around. And I have your names, so I'm gonna try and put names to faces. I'm horrible at that. So I will get your name wrong. I guarantee it, even if I've known you for years, many times. Okay. But let's go around the room and just tell me what your name is, why you want to take this class, and your preferred pronouns. Okay. Okay.
Hello, my name is Lucia. My first pronouns are she, her, and
No, I don't want to.
you may use the black.
That's true.
So my name is Steven. My preferred pronouns are Eden, and also that's it.
So hold on, let's clarify. They both work for me at the observatory, so I thought it was important that they know what they're saying. So, okay. Okay.
All right. I am Trinity. I go by somehow transfer, so this is all part of the process.
Okay, cool.
I'm Isabel, she, her, and I also work in kitchen. I'm sorry. I go by she, her, and I'm minoring in astronomy, so.
Okay, wait, so story or
Sorry.
theory?
Sorry.
Okay.
My name is Eduardo, I'm going again, and I just want to learn about the universe now.
Cool. Can you find it?
Catalina Castillo, majoring in physics, aspiring to become a bilingual science teacher. She, her, and
Cool.
My name is JJ Martinez, and I'm also minoring in astronomy. So,
Wait, can you see your name again?
Jahir.
Shahir? Okay, perfect.
My name is Alfred, and I've also been a minor in astronomy.
Cool.
Pronouns either.
I'm Kobe. I have to take this class in physics. And I'm Ethan.
I love that favorite response. I have to.
There's Gonzalo Ortiz, the pronouns are Eden, and take this class just because I wanted to minor in astronomy.
My name is Andrew Macias. My pronouns are Ethan. And taking this class because I want to learn.
Right, can you pronounce your name again? Sorry, Andrew. Andrew. Okay.
Hello everyone, my name is Andres, and I'm studying this class a little bit.
Sorry, I was looking at there's Andres and Andrew. And I'm like, wait, I didn't see the word Andrew, which is written down on my sheet. And then in the back there, we're doing name, preferred pronouns, and why you're taking the class.
Okay, my name is Teresa Eddie. I go by Terry. Just the G.
Just the G.
Credits, yeah.
Okay, cool. So we have Zori and Zuri. Okay, that won't confuse me at all, I promise. Okay, so that's me again. Let's just talk briefly about what the course goals are, and then we'll look through the syllabus and everything after that. This course is primarily for your scientists. Hopefully you're in the intro astro scientist class and not the intro astro class, because that was last semester. This is teaching you critical thinking skills, how to think, how to reason, how to argue, how to extrapolate from information that you're given. Okay, you're gonna learn why the universe looks the way it does. You're gonna learn how we know the things about the universe. They weren't given to us on high. And you're gonna appreciate how cool the universe is. So the right answer to why you're taking this class is because it's sick. Right? Fucking awesome. Okay. And you're gonna figure out what we don't know yet, which is a lot. Okay. We're gonna start by looking at like sizes and scales. We'll do that a little bit today, and we'll move into it more when we get into some of the labs associated with the scale. It's kind of hard to prospectively think about. You're gonna understand here's the Earth. Okay, it's a tiny dot that fits inside this bigger dot that fits in this bigger space big. Bottom line. Okay. You're gonna understand how the Earth being a sphere influences our understanding of the world. So you look out into the space, it's going to change where we are in the sphere, and it's what we see. So you have these things called celestial motions. That's the motion of the night sky throughout the year and throughout a day. We'll talk about eclipses and moon phases. We'll talk about some of the terrestrial planets. Terrestrial means like Earth. So that just means like rocky surface. And so this is a really cool video of the top of the lander here. As it comes down, you just basically strap an iPhone to the bottom. They took a video as it descends. What do you see here? Good. Yeah. What do you see? Sand and dirt. Rocks. And so then you see like oceans. Ocean. Any like signs of civilization? Is 7-Eleven? Okay. What's that? It's like a piece of the road.
Oh.
Not on Mars. Not on Mars already. Okay. All right. We want to talk about why there's no abundant life on Mars or Venus, our two closest neighbors. Why are we here? That's a pretty big question, right? So if you look at us and our nearest neighbor, these are not to scale. Venus is a awful world. Temperature at the surface melts everything, including all of the electronics and anything that we send there. We try to land there, survives about 45 minutes before it melts. Fun. You go to Mars, great planet, very poor atmosphere, just like thin. It's suck to breathe, there's carbon dioxide that would kill you instantly. Cool. We're going to talk about why Earth is so different from Jupiter. That is to scale. So all the people who have ever existed, right there. Everyone, all the friends, all your ancestors. And this is the size of the Great Red Spot. This is larger than this. Why? Okay. This is a recent picture of JWST Space Telescope. And what you can see here is these images that are coming out of JWST are absolutely beautiful. So we're going to work them in. One of the biggest problems I have in teaching this class, I can't be on Twitter beforehand, which is ruins my lecture. It's something new that's come out. I have to like work it into the beginning. So I'll try and be respectful of our time, but we're going to get derailed. So what you see here, that's a Great Red Spot again. This is in the infrared, so it's slightly different than what you're used to looking at. Infrared light is what we give off. It's, for example, what snakes see. So if you could see like a snake would, this is what Jupiter would look like. And you have these little moons. I could turn all the lights off. Am I hitting all those, Andres? Okay. All right, what's this? Yeah, there's a ring. Very faint. Very thin. Okay. Don't fall asleep. Here's another one. The colors here are just negatives. Now these are they're colored after the fact because you can't see in the infrared. This is helpful. So you can see all of these violent storms and energy is coming out through these storms. We'll have to understand all of these. Okay. This is a survey class. So for those of you taking fluid dynamics, you won't be doing that here. Okay. We'll talk about what the hell is the deal with Pluto. Used to be a planet, now it's not a planet. Can you turn the light back on? So one of the bonus books that I've been putting for this class, you can borrow it at any time. How I Killed Pluto, why it had it coming. The planets. Okay. We want to talk about why other solar systems, how they're different from ours, how they're similar to ours, and what finding out about their presence has told us about our own solar system, whether we're unique or not, or they're very common. I think that's what I'm looking for. Okay. Why it's not hot? What does that mean? It's not hard, right? Do I make fusion when I do this?
No,
How hard do I have to hit it?
really hard.
How hot? Tens of degrees, hundreds of degrees,
Like millions and millions.
10 million, yes, about 10 million. Good order of magnitude. Okay, what's that? Yeah. It's not big. Okay. Mercury small. Okay. Do stars exist forever? We can't all know that already. What am I supposed to teach you? All right, we're gonna learn about that. Is interstellar accurate? Kind of. When is it accurate to? Like minute 45. Okay. We're gonna talk about what kind of galaxies exist and what gives them their shape. Can you hit the lights again? Sorry. Overshare is just a button for that. Might be. All right. So this one here is a JWST image. Anytime you see a JWST image, you will know it is different from a normal telescope by what feature?
The six.
The six-pointed star. Okay. This tells you that it's JWST. And these are also foreground stars. So these are stars in our galaxy that are really bright. Whereas every single dot here is its own galaxy. So if you look here, this little spirally boy, that's a galaxy. Whoa, that's a lot of galaxies. Okay. And then we'll talk about, is there an edge to the universe? You may have heard about the Big Bang. Raise your hand if you've never heard of the Big Bang. Okay. Okay, so how could everything just Big Bang into existence? We'll talk about that. We'll talk about what the heck this is. Anyone know what this is? The what?
The observable universe.
Yeah, but what is it?
Cosmic background.
Yeah, this is microwave background radiation. Why is it colored all funny?
Because we didn't see it.
Yeah, this is a form of heat, and there's temperature fluctuations here. Small ones, but they're meaningful. Okay. What's the course not? Memorizing constellation. Now, that doesn't mean if you came here for constellations that I won't also show you a few, but you won't have to memorize them. Okay, this is obviously done. Any questions? Okay, you want to hit those lights again? Thank you. Sorry. Oh, that's the last time, maybe. Okay. If I could just get rid of this one, I would hold to shoot it with a BB gun, but all right. So if there was a switch you could flip that would improve your grade letter by a half, would you do it? Raise your hand if you would do it. What's that switch? Put your phone away. It's literally put your phone away. So if you use it more than 5 times in class compared to if you never, you on average get about a grade difference or a half grade difference. Okay. Okay. So this course is going to be comprised of several different components. So obviously you're in a lab room right now. We just talked about the fact that there will be labs. Anyone surprised that there's going to be labs? Cool. So I just want to make sure. We also have a TA or an LA, I should say. Caesar. So Caesar will be helping out usually in the classroom. He'll walk around. And when we do these things called lecture tutorials, these are basically done in pairs or groups of 3. So you'll make a friend for the day and you'll talk about the problems. And the problems on there are not going to be created. What you're supposed to be practicing is the process of problem solving, process of extrapolation. So feel free to get into a little argument, not like a real one, like a healthy debate, where you ask yourself questions, you want to question what you know, you want to question what you understand. Okay? Okay. Does anyone here like a living calculator? No. Is that a skill? Is it a monetizable skill?
Yeah.
No. Those calculators are free. Okay. So this is a great tool for calculating and converting units online. If you've never used it before. You know, I never used Wolfenbüttel. Oh no. Yeah.
No, I was just answering your question.
Oh yeah. Okay. So if you never used it before, I would 100% recommend you just play with it. It can take very complicated formula. And as long as you're specific, it's quite smart. So for example, I put in 25 inches in a month. It's just a weird thing to have put in feet per minute. And I asked it to do the conversion for me. And not only did it do the conversion properly, here's the result, feet per minute. It also gives me other conversions, just in case I'm bored. And it gives me comparisons. So that I can feel like, is this right? Okay. And it tells me how to interpret the result. That's a speed. Length per unit time is a speed. So if I was expecting something like a mass, I know that I put it in wrong. Right? Sometimes when you put it into your calculator, you put a bunch of numbers in, you don't know that you divided and you're supposed to multiply. Screwed, right? Here you can see the whole process, and it also shows you what it thinks you put in. It thinks you put in inches over month, right? Instead of inches times month. It'll sometimes tell you, I interpreted this as this. Okay? So you're gonna get these slides, obviously, but open this up and use it for your own. Okay. More importantly, oh, there's a website. More importantly, this one. So if you took my fluids class, you've already seen this. This is ChatGPT. Anyone familiar with this? Sure. Do you use it?
Yeah, I read the website.
Oh, nice. So is it helpful? Yeah. Okay. Is it very powerful? Yeah. Yes. All right. So here's what I'm going to ask you. Up here in the top right-hand corner. If you're not familiar with what ChatGPT is, it's an online AI that you can ask things and it will give you answers. Okay. So I asked it to please rank the gas giants by density from least to most. This is its response. You have a look, and if you're in my fluids class, you have to be quiet. Don't tell your friends. What's wrong with the response? What? Yeah, just the gas giants, just the 4 planets, just Jupiter, Saturn, Uranus, and Neptune. What's that?
Out of order.
Yeah, it is out of order. So even though it has access to the numbers, here's 0.68, here's 1.3, and here's 1.27, still gets it wrong. ChatGPT is a predictive language to talk system, so it knows usually how words go in the right order, but it can't actually understand it. However, it doesn't mean it's a good tool, bad tool. Here you can see that it will answer questions about Neptune, right? So you can ask it about Neptune, and it'll use what most commonly comes in those sentences as a response. But it doesn't know what it's saying. So it cannot be fully relied on. And in fact, this is great. Because in most things in life, let's say you're talking to your friend, very confident friend, would you just automatically accept what they have to say? Or would you think about what they were saying before you reinterpreted it? Right? You think about it, hopefully. So this is what we're going to practice. You're going to use AI in this class. I strongly recommend that if you haven't made a profile, you make a profile, use your EDU, get access with it, ask it questions, see if it can explain stuff to you that you didn't know before. You used it already? You liked it?
Yeah.
Yeah. Okay. So part of the homework will have this in it. I'll ask you to ask ChatGPT, and you will interpret that answer and tell me whether it's right or wrong. Fun? Okay, so the weekly homework will look like this. There's 5 different types of problems. They'll show up in different quantities. I'm a stickler for words. I think words are important. I think understanding what they mean is important. So you write a definition, how to use it in a sentence, for example. So you feel confident using the terms in this class. There'll be questions arguments between the students. The feedback that I get is this is usually people's least favorite type of question. So student A says blank, student B says blank, who's right or who's wrong, or both wrong or both right. And you have to interpret that. Okay. This one here is the one we just talked about. We'll have ratio problems. That's where your math's going to come in. But it's never, the important thing is never like, oh, 10 to the 26 kilograms. That's medium. So I'm gonna always try and have it in a ratio. So compare it to the moon, compare it to Earth, compare it to the sun, okay? And that's way you can have some sort of more natural intuition for those values. And then finally, inference. What I'll do with the inference problems is I'll present you with a scenario, and I'll tell you in your mind, you have to change part of the scenario and what happens. Okay. It's like fair types of problems. Okay. Now we'll require metacognition. Meta just means thinking about. Meta is thinking about what you thought about. So this process of metacognition will ask you to rank your confidence in each of your answers. Every homework will have 5 questions. I'll try and make them one of each, but if you don't have enough ratio problems, you'll get double of a certain type, and you'll just rank them. If you're not very confident, you get less points for that question. If you're very confident, you get more points for that question. However, if you're very confident and you get it wrong, what happens? You lose more points. So in general, this grading scheme is really nice for people, right? Because if you have 3 problems, you're very confident on one and you get that one right, it's worth the other 2 if you just normally didn't get it. Does that make sense? I'll show you the breakdown later on if you're interested. Okay, exams. Are there exams in this class? Raise your hand if you think there are exams in this class. Raise your hand if you think there aren't exams in this class. Why do you think that?
We have labs.
You have labs, okay? The right answer there was I read the syllabus. There are no exams in this class. Okay? You want exams? Raise your hand if you want exams. Okay, so everyone close your eyes so that you're not like ratting out your friends. Close your eyes. Raise your hand if you want exams. Okay, all right, that's fine. Everyone open your eyes. Okay, so there's no exams. What about the textbook? Here's some other bonus textbook. Also, these snacks are. You want snacks at any time? You need snacks? I know you didn't get snacks. So this is the textbook, but it's not exactly this textbook. There's. Oh my God. There are many versions of this. So as long as it says the cosmic perspective and it has these authors, I'm okay with it. I think this is the 7th edition. They're on the 9th edition. You can buy the book, you can rent the book, I don't care. Do not buy Mastery. Do not buy Mastery. Mastering is a ripoff. Okay. Anyone buy Mastery? Okay. There will be help sessions. So if you have not filled out that when to meet, who has not filled out that when to meet? Please fill out the when to meet. Ideally, try to do it today so that I can plan the rest of my life. And then Caesar will also have sessions, and they'll help you with the homework, help you with things that you missed in class. They'll be in a classroom similar to like this, so it's not in just my office. Okay. Any other questions? Okay. Let me show you the course calendar really quickly. All of my classes use a very similar calendar technique, just because this is how I organize my own brain. Take them. Okay. So here's the calendar. So you can see this is us. Oh shit, that's awful. Hold on. That's better, right? Okay. So this is link inside of Canvas. You'll see like content schedule, and it'll tell you what you should read. I prefer if you read before class. Why is that helpful? Yeah, you're familiar with the material. I ask you a question, you answer it. Is that always possible? No, I am. We'll do lecture tutorials. I'll try to tell you a little bit ahead of time when the lecture tutorial will come in. We won't do one today. I'll just move this over. Whoop. And the first homework will be due at the end of the week. Okay. We'll try to do one a week. So sorry. Okay. And the moon phase is here. So the moon phase is how full it is, and the number is small, the moon is not visible, and the number is big, the moon is very visible. Okay. And then here it's not very full. And we'll try and do a lab. Obviously this got all screwed up because I thought lab started Wednesday. This whole thing's gonna move over, I'm gonna rearrange it, but we will have an open house observing at the observatory, assuming that it's not too windy, assuming that it's not raining, right? And we'll just go out there, we'll set everything up, you look at cool stuff in the sky. Not a question? All right, questions about the content schedule? Anything else in the syllabus we should address?
Question about the homework you said to not get the mastering
Yes.
reads, like, I'm gonna be in the campus itself to work on and submit it. Or in-house.
There's 14 of you. I prefer to have physical copies because Gradescope versions are always like super grainy and really hard to read. But I might just pass out this paper. And you can turn in as many other.
Are we going to the observatory today?
No.
Oh, right. That's fine.
Very windy. And cold. Okay.
So it's a lot.
Sure. Yeah, let's call it that.
I didn't say that at the beginning.
Because it's not really canceled. It's like come to observatory and you instead
Oh, on Thursday?
on Thursday.
Yeah, next week. that's the same.
Oh, well, we're required.
Well, but okay, so like requirements in this class are very like, we can't go today, it's very windy. Can't operate when it's really windy. Can't operate when it's raining. For obvious reasons. That makes sense? Okay. We'll need to go up a couple times, right? You have a whole lab on the moon, you have a whole lab on deep sky objects. And the thing about observing is it happens when it happens. So, you know, I can put it on the calendar and I can say, this is the day that you should come. And, you know, if I only did it once and it gets rained out, now you don't get to see those objects. So we offer them multiple times throughout the semester. If you can't make it this week, that's totally okay. But just know, you know, later on, look at the schedule, if you missed all of the observing labs, that'll be a problem. Okay. Yeah.
So for homework this week, physical copies, we have to come on Friday, right? Or like one week for the next week.
I'll probably give it to you on Wednesday and you'll give it back to me on Wednesday. A week. I just haven't figured out the details yet. Okay. Okay. Hello. Okay. So let's talk about navigating the universe itself. We're gonna start with sizes and scale. And then we'll talk about the nature of science. In science and nature. Galaxies. What's not a galaxy in that picture? Yeah, right there. Okay, a lot of this class is me putting stuff up and you telling me what it is, even though I already told you this. Okay. Future stuff. There's another one right there. Okay. So what's wrong with this picture? They're all lined up and it's not to scale. What does that mean? It's not to scale.
Planets are like the right distance apart from each other.
Yeah. So these sizes are correct. But these sizes next to each other are not. And they're not lined up like that. Very, very rarely happens. Some of them don't even live in the plane. Some of them live above and below. So let's build a correct solar system. Okay. So this is going to be 1 in 10 billion. Anyone ever here build like a model train or something like that? You know what this scale is? Yeah. You want to explain what that means?
So like, for model springs, it's kind of like,
the scale that they talk about, if it's like HO00C scale, it's basically like 1 to how they shrink it down. So if it's like a 1 to 32 scale, it's the 32nd like ratio size of the actual size. And there'd be like 1 in 4, 1 in 8, 1/16, 1/32, 1/64. It's basically just the size ratio.
Exactly. So imagine that this is a 10-foot table, and I want to make a 1 in 10 model of it. I need 1 foot representing, right? Okay. So we're gonna shrink this by 10 billion. All of the sizes are gonna get smaller by 10 billion. So how big is the Earth? Microscopic? Everyone else?
Marble.
Marble? That it? That's the only options? Grain of sand? A quarter? So people are going small, okay, so no one's going like car, no one said like this room. Take the Earth, we shrink it down to 10 billion. Okay, what about Jupiter?
Tennis ball.
Tennis ball? Grapefruit? Basketball? Okay.
Watermelon.
A rock? Well, rock's very ambiguous.
Yeah.
You play rocks.
Size.
Okay, that's a way around it.
Watermelon.
A watermelon? Okay, okay, but bigger than the Earth or smaller than the Earth? Bigger than. Yeah, you already said that. Okay, so what about the distances between them? So let's think about this for a second. Okay, let's say we make the sun a grapefruit. Make the sun a grapefruit. We have all these planets. How far do we put Mercury and how big is it? So let's say this is not a grapefruit. Imagine this is grapefruit size. Okay, where's Mercury?
Can't even see it, but it's really big.
Very close. Okay, someone want to do Mercury, please? Okay, Lucia's gonna be Mercury. So everyone has to vote on where Lucia goes.
Right here?
Between those dots?
Closer, closer, closer.
Closer? How's that? Raise your hand if she should be closer. Raise your hand if she should be farther. Okay, she gets closer. Okay,
Oh, thank
now
you.
take a step.
There you go.
Take 2 steps back. Okay, raise your hand if she should be closer. Okay, raise your hand if she's about right. Okay, raise your hand if she should be farther. Okay, a little ambiguous. All right, let's do Venus. Someone's gotta be Venus. Okay, where do we put Isabel? Is that good or farther? Smaller, closer? Think that's good? Raise your hand if she should be closer. Raise your hand if she's good. Raise your hand if she should be farther. You guys who are planets can also vote. Even though you're planets, you can still vote. Okay, raise your hand if she should be farther. Okay, all right, we're gonna keep it there. All right, someone's gotta be Earth.
Only we can stay up.
Okay, all right, where are we gonna put him? Right there? Raise your hand if he should be closer. Raise your hand if he should be farther. Okay, take a step back. You can also go a little diagonal if you have to here. Should he be farther than that? Think that's good? Raise your hand if that's good. All right, all right. Now let's do the best planet, Mars. You want to be Mars? All right, where do you want to go? Yeah, you're in orbit. You can orient however you want. Right now you're in a line, but that's totally okay. You just want to be distant to the sun, right? Is that good? As long as you have to get closer or farther. Raise your hand for closer.
Wait, who is he first?
What are we scaling? This is between him or the sun?
So we're doing distance to the sun, and we're imagining everything's shrunk down to the size, the sun's the size of a grapefruit. We haven't even talked about the individual planets, how big they are, right? We're just trying to orient them on the same scale. If this is where the sun is, we think that's where Mars is. Farther or closer?
I think further.
Say closer,
Oh,
say farther, raise your hand for closer. Okay, raise your hand for farther. Everyone's farther, okay, so you're gonna go back a little bit to the edge of the room, okay, good, no, that's as far as I can legally let you go. Then you're just running, okay. So Jupiter is not gonna fit on this scale, is that correct? So you guys gave it up on Jupiter, so
Outside
you think it's
the
outside the building or outside the room?
outside the building.
Okay, raise your hand for outside the building. Raise your hand for outside the room. Okay. What about Pluto?
Montana.
Montana? Okay, raise your hand for Montana. Raise your hand for something closer than Montana. Raise your hand for something farther than Montana.
Corona.
Corona, okay. Okay. All right, let's figure this out. Don't move, don't move. How big is Mercury?
That's
Yeah, the sun's a grapefruit.
That's it.
Oh,
Oh my God.
An atom.
Okay, one at a time. One at a time. Raise your hand.
Needlehead.
A needlehead. Okay.
That's pretty good.
Venus?
Uh,
A jelly bean? Okay, so you can hold a jelly bean for yourself? Is that what you wanted? No, you just want one.
Yeah.
Okay, so is that your size or is that?
That's just what I wanted.
Okay, okay. What's Venus's size? What?
I'm saying it might be somewhat of a jelly bean.
Okay, you're gonna go Venus is the jelly bean? Bigger or smaller?
Small.
Smaller.
I don't know what it's called.
Okay. Earth.
That's-
Size of the sandwich he has left or
Yeah. Probably a marble. No.
a marble?
Grapefruit? No.
Bigger than a marble?
Earth is
Smaller than
Smaller than marble.
Smaller than a marble.
It's not.
Okay, all right. Jupiter?
Marble.
Marble. Everyone likes a marble because a marble can be really big or it can be really small. Oh, shoot.
I like it.
That's not a very good choice then. What's another size?
Standard marble.
Standard marble. Okay. All right, we're gonna use standard marble. Okay. Pluto?
A cell.
Oh, what?
A cell, like a cell.
Well, we said atom before, so it has to be smaller than.
Oh,
atom.
an electron.
That's incorrect. All right. So these are the right sizes. See how many we got right?
Yeah.
Hey! Someone got my slides beforehand.
Standard one.
Okay, so head of the pin, that was good. Head of the needle, salt, sand. Wait. Why are you moving? Oh, we don't know how far away we are.
I was just standing there.
My God. All right. So the first one is Mercury. It's 19 feet away. So where do we have to move Lucia to? Like to where, yeah, back to the end of the room. Okay. Venus, 36 feet away.
Oh, you're way up.
So you have to basically go into the corner of that room. No. Now everyone can sit down. The Earth is about 50 feet away. Okay, so outside of the room, not yet outside of the building.
Maybe that lab.
Yeah, probably the next door lab. Okay, calm down now. Let's see.
Okay.
Too much sugar. Too much sugar. All right. Mars, 75 feet away. So this is when we start to get outside the building. Okay. Mars is almost outside the building. It's the size of a big piece of sand. Jupiter, 250 feet away. Yeah, let's see, where is that? Yeah, you're probably near Jack Brown, probably near the parking lot. Good. And Pluto, of course, about a third of a mile away, so not very big. I think Jupiter.
I mean, we could do scale, like.
Yeah.
So in fact, we will do. That'll be one of the first labs we do. We'll map it all out. We'll have fun. I'll bring fruit. We'll eat it. Okay? It's a very hands-on class, as you can tell. So now here's the big question. And if you know the answer to this already from the observatory. Okay. Oh shoot. Where is the nearest star on the same scale? The nearest other star, not ours. Obviously, the sun is quite close. Okay. The sun is the size of a grapefruit. And it's here in the middle of our classroom. Where is the nearest star? You think it's at the moon? It's a little closer than the moon.
Twilight across no, maybe like half the US, like 1,000 kilometers.
Okay, so like Denver or something like that?
Yes.
And from Kansas. That seem right to folks? So you're saying this is the first star, and then it's nothing until you get to Denver, and then there's another star. Is that what you're saying? I'm just making sure I'm interpreting.
Yeah.
And everyone agrees with them, or you think is there a closer star?
No way. I think-
No way. Yes way.
I think.
What's that? You think it's in California? Okay. Okay, raise your hand if you think it's in California. Okay. Raise your hand if you think it's in Colorado or that distance. Okay, raise your hand if you think it's farther. It's farther.
Water? Oh, is it like Europe, like across the US?
It's in New York.
Oh, that's sad.
Wow. It's not sad, it is what it is. And it's about the size of a cantaloupe, an orange, and an apple, all hanging out together. That's the Centauri system. So Alpha Centauri is our nearest neighbor, 4.3 light years away. And it's Alpha Centauri, which is the first one in the Centauri system. There's 3 of them. Okay? And in between them is essentially nothing. Empty. Okay?
Pretty much.
That's original canvases, exactly. Okay. So let's talk now about the nature of science. Was that good? Do you have questions about this? We're gonna move right on. The nature of science.
You're alone.
We're alone. Yes. And the distances, the thing to remember there is the distances are big. They're mind-bogglingly big. We are quite used to things being close to us and being able to travel to these things. You cannot. Okay? Light is the messenger. That's what's giving us this information. We watch Star Wars and they navigate between all these planets. They try to avoid the asteroids. It's not like that. Asteroids are very far away from one another, and getting between planets is extremely difficult. But it's less 15. We just get it up. Okay? Okay. Let's talk about the nature of science. We're going to talk about identifying scientific and non-scientific statements. So we'll make some scientific statements, and then your friend will have had a little bit too much that night and have heard that you're taking an astro class and ask you non-scientific questions. You'll have to know which ones you can answer with certainty and which ones you say, well, we don't really have an answer for that. They get frustrated. They're like, well, that means you don't know anything. And say, no, that's not really how science works. Okay. Because we have to talk about the scientific method. We're going to practice that in class. You're going to make inferences about something based on your knowledge. You're going to use hypotheses that exist, and you're going to make assumptions about what will be there. We'll talk just briefly about Fermi problems, but I don't like English. Okay. So we're going to do this slightly in order, so you can also find out like what the distribution of signs is here. So if you're a Pisces, I also didn't print that many of them. If you're a Pisces, please come pick up the Pisces from here. Okay. And don't share yet because we're gonna do something with these. Just pick one. Yes, you look at yours, but you can read yours and you can sit down again. Okay, and then don't talk about them. Sophia? Because we're gonna make some comparisons afterwards. Okay, Taurus. Okay, Virgo. No Virgos. Libra. Aquarius. Cancer. Aries. Sagittarius. Leo. Capricorn. Gemini. We did enough. Yes. Oh, okay, so let me know when you read it just by like looking up at me. You get one? You read it? Okay. So now we're gonna do a little, how well did today's horoscope, for you personally, describe it? Was it A, very well, they correctly identified everything that I'm feeling? And the way that I like to do these in class is that you're just gonna use your fingers. So 1 is A, I should probably change it, but I'm not smart. 2 is B, 3 is C, 4 is D, okay? And I'm gonna read them off, and then I'll ask you to, 1, 2, 3, and we'll put them up on our chest, so I can see yours, but so that you're not like shouting at your answers, okay? So A, very well, they correctly identified everything I'm feeling. B, well, they identified most of what I'm feeling. C, acceptable, they identified some of the things I'm feeling. Or D, 4, they mostly identified things I'm not feeling. When you're ready, just put your hand up on your chest. And let's go. Okay, I got mostly 1s and 2s, couple 3s, no 4s. Pretty good, right? Pretty good. Astrology 101. We're done? No. Okay, hold on. So, what about it made it seem accurate? No, but what about it, yours made you feel like it was accurate?
It talks about how there are some decisions you made that aren't very secure, and it's like, well, I mean, like, how am I supposed to be secure then?
Okay, all right. Anything else? Yeah.
It's like everyday relatable stuff that like did one day and then take the next one.
Okay, so you felt like it fit not so much today? Any parts that seem too true to be coincidence? Yeah? Yeah. That's how you know that it's real, right? I know P. Was it obvious that you all had the same one?
Yeah.
Okay, so of course you all have the same one, there's no predictive power. Okay. Let's talk about this in more detail. So when you think about science as a whole, right? How do you distinguish it from non-science? So I mean this has stars in it, so it's gotta be pretty scientific, okay? And what's meant by scientific theory? And in particular, we're gonna start by thinking about this difference. Astrology and astronomy. When you're an astronomer for a decade, your friends will still call you an astrologer. I promise. I promise. Okay. And what's the scientific validity of astrology? Why 0? True. Okay, here's some different words here. We're gonna go through this so far. Now, this doesn't mean that we can't use it for fun. Okay? If it helps you to understand your own life, I'm not here to shit on your brain. What I'm trying to say is that there is something we call science, and we call nonsense. I'm drawing a distinction. Let's ask a different question. Is luck real? Is luck real?
I would say.
You say, so raise your hand if luck is real. Is anyone here unlucky? Cody? Is anyone here super lucky? Also not won the one. I won $2. I don't think that counts. Okay. Interesting that you say about the lottery though, right? Because if there were lucky numbers, let's make a supposition. Imagine 13 is lucky. Okay? You just always play it in the lottery, right? Okay. Interesting. So how does one determine whether luck is important? You have to make some statements about it, right? See if it tests me. Okay. And this is the distribution of white ball, just the last ball frequency. So it can be between 1 and 56. That's got almost everyone's lucky number in it. What's your lucky number? Yeah. What's your lucky number? Yeah.
47.
47. Oh, it's in here. What's your lucky number? 33. What's your lucky number? 13. Yeah, a lot of people like them in the teens and like below 10, but it goes up to 56, so it's got everyone. And what's the luckiest number? No. No. These are even. Believe it or not, this is a even distribution. It goes up and down because everything about it is random. So unfortunately, when I roll the die, right? Let's say I roll one die. I have a 1 in 6 chance of getting any of the numbers that I want. But if I roll 2 die, I'm most likely to get what number? 7. If I combine both of them together, I'm most likely to get a 7. There's more ways to make a 7 than the other. Okay? Or change the distribution. Here, this is an even distribution. You're just as likely to get any of these numbers. And even though it looks peaked right around here, they said that's the most important number. Because look at the variation. This one below, it's not 4 times as unlucky as one right before. She's like, oh. We can take a statistics class and I'll show you. And in fact, that segues beautifully into this book. This is a fun bonus book. This is called The Drunkard's Walk. I recommend this to every student. I read it in undergrad and I still have many copies of it because it's amazing. It's about the human brain's inability to see patterns where there are. And it's maybe overachieving nature of finding patterns where there aren't. We are really bad at determining randomness. We look at that and we think that this is 48, very lucky. Now, you go out the next day, you put $10,000 on 48. What happens to your $10,000? It's gone. Okay. This is why we have to think about these things critically. Okay. So in fact, luck itself doesn't appear to be in our numbers. Maybe we can make some other hypotheses about it later. So these both astronomy and astrology, they have roots in the night sky. Look into the night sky. In fact, Taurus constellation, all of these are constellations in the sky. Right? And there's this like how scientific would you consider astrology with horoscopes? Most people think of them as very scientific. And no, I'm not looking only at you, sorry. And I don't think of horoscopes as very scientific. What's the difference here? Just like my friend. Okay. So it sounds sciencey, but it's not. So astrology attempts to make use of the position of the planets, the sun and the moon, to explain occurrences in our daily life. Like you should really go and spend some time for yourself today. I don't remember what these ones said, but like, you know, you're going through a state of flux because the moon is in Jupiter, right? When Mercury's in retrograde. So you now get to flip people off while you're driving, right? Let's excuse bad behavior because Mercury's in retrograde, right? No. Okay, but astronomy is the study of objects outside of our planet in an effort to understand them, right? So this one here, the back one. Why does it do this? Okay. Astrology tries to explain our daily life. Astronomy tries to explain what the stars and planets do. Okay. That's the major difference. So that's a little bit of similarity. Astrology lacks a combination of things, consistency. So, for example, you go online and you look up your horoscope today for your sign, and you compare it to any other website, they will not be the same. So if I told you that the moon is gonna rise at 6:45, you went down the hall and you found another astronomer, and they told you that it's gonna rise at 6:13, you have a little problem, right? But when the moon gonna rise, want to know when the moon's coming out, and find out when the moon's coming out. So astrologers cannot give consistent predictions. They don't have any predictive power. Right? I can't put money on anything that an astrologer says unless I'm really interested in losing that money. That seems to be the way that most of my stocks are work, but that's fine. And most importantly, what's the physical mechanism? A lot of this class, we're going to talk about not just how something is moving, but why it seems to be moving. There's no physical mechanism linking. Right? How does the moon influence my mood? Much more influenced by whether or not I'm thinking. So this was one that I did for last semester. This is my horoscope, of course. And yeah, so this one says things can be rather hectic at work. Be happy. Try to get involved, jump in the fray. Yes. Persuade both parties to take hold. Sharing your stance of relative program. And that's the opposite of what this one does. Now I need to be a balancer instead of jumping into the fray. You can find a horoscope that'll tell you whatever you want. It's pretty cool. Anyone know the ancient reasons for like horoscopes? Yeah, it's a very old tradition. And even when we get to Galileo, which I don't have a book on Galileo here, but we read a book like this that talks about Galileo, we get paid to do horoscopes for humans. They wanted it, they paid for it. Might as well. No one pays me though. Okay. So it has to be make testable predictions. We already talked about the fact that it fails to do that. They say that they use the sun, moon, and the 8 planets to make predictions. However, we didn't always know about the 8 planets. And in fact, we have a bunch of dwarf planets now. So why weren't all those old horoscopes wrong? That's the word. And what happens when you demote Pluto, or you accept Ceres into your life? Ceres is a large asteroid, minor planet, or planet. But you have to calculate for Ceres as well, because it's closer. I've never dealt with these things. Okay, finally, we need a physical mechanism. So astrology claims that electromagnetism or gravity makes changes in our lives. And this one's a little tricky. Gravity definitely does affect us, but what's the most prescient form of gravity that you're aware of right now? What's a dominant form of gravity? What's the dominant force of gravity? The Earth. Okay, it's all headed towards the Earth. Okay. And after that? Here's the sun. The moon. Okay, here's the moon. The moon is small but close. Sun is big but far. Okay. What does the moon do to us that the sun doesn't do? Tides. So it can move our whole ocean. And we're actually going to understand that phenomenon when we start to talk about gravity. So gravity seems like, okay, well, maybe that's the reason why my mood is so bad. I run into this for a little bit today. That makes more sense. But definitely not from Mercury. Mercury is small and far. Jupiter big but far. Okay, what about electromagnetism? That one's tricky, right? Because like, I don't know what that is. I can, whatever. So what is the let's think about like, okay, like the gravity from Jupiter is small, fine, it's far away. Like the electromagnetism gotta be big, right? Okay. Jupiter's magnetic field has the same strength of you as your toaster does. So maybe rearranging your kitchen is gonna heal your chakras better. Okay, all right. So in this class, we'll be treating physical mechanisms like electromagnetism and gravity as the forces that keep everything together. There's not hidden forces. Okay, there's not hidden variables. Okay. All right. So let me ask you this question. Which of the following claims can be tested by scientific means? Is A, blue is the best color for walls? B, people born when the sun is in the constellation of Leo are more financially stable? C, God exists? Or D, the final thought of Abraham Lincoln was about the fate of this country? Which of these claims, can be tested by scientific?
Okay.
No, hold on. We're gonna do a little chess. We want to. Where you see these choices here? Let's try to sample the class. Richard, this up when you have your solution.
Is one.
Yes, A is 1, B is 2. I'll change that, maybe. Okay, got a lot of ones. You vote already? Okay, why don't you turn to your nearest neighbor and ask them what they chose and why?
Well, I thought one because. Yeah, I'm thinking the other two.
Standard has
Probably we can just survey a bunch of people and ask them what's the best color for one.
or you
I mean, it's
will reflect a lot of light.
like, it's, there's what can be tested, that actually, I can't test the other stuff. I mean, it'd be a lot harder. Yeah, that's what I was thinking about, but
Okay, let's try and revote here. Put your fist back up when you're ready to revote. We'll vote on, when you have your fist up, I'll do 3, 2, 1, and then I'll see everyone's decisions, okay? Put your fist back up when you're ready to revote. 3, 2, 1. You can't go back and forth. Okay, interestingly, some people moved over, still see between 1 and 2. But no one liked 3. No one liked 4. We get rid of it. Someone wanna represent 1 or 2?
For A,
Girlfriends here.
for A, you could do like surveys and stuff and get like the average of like, if people do think that blue is the best color for walls.
Okay. Okay. So that would be determining what? Is that a fact? Would that be determining this? So now we have to think very carefully, right? I'm gonna have tricks components. Because this here is not a very good question.
I was gonna say, I think the B,
Yeah,
because it's like, so they're testing to see if people are born as Leos, if they're financially stable or not, right?
Mhm.
So then you can pull like a pool of people who were Leos and then just like, survey them to see how, if they're, money, financially wise, if it's an actual true statement, just by
Okay.
pulling up their income or anything like that.
okay, so you could say of the 1,000 people we looked at, 90% of them were destitute, and they were all Leos. Right, that would disprove it, yeah,
well, what determines what is financially stable?
very good, okay, so maybe this isn't well posed. Right.
Because whatever money you make might not be the same money I make, but that doesn't mean I'm not financially stable.
Sure,
That's
yeah.
what I can do.
So this one could be not a well-described question, right? Is this a well-described question?
No.
No. Can we test something that's not well-described?
No.
No. If I said blue is the best wall for Mateo's office. Right, that would be a little bit better. Maybe you could, it's not blue currently. But you could maybe put a stipulation on it. You could say, well, we could test it. You could say for holding inmates, blue is the best color for keeping them calm. And you can test that, you can see if that's true, right? This is too ambiguous. This might potentially be too ambiguous. What about this one? Yes or no?
We've been trying to test that for the past 1,000 years.
This answerable?
I would answer the.
What about this one?
Bring it back.
I would not be thinking about it.
You never know though, right? Well, he was watching a play. And he got shot from the back. So it was very unlikely that this was the final thought. Unless he was just ruminating on the fate of his country without knowing who was that. Okay. So that was another trick. We played some tricks in this class. So if you don't like tricks, you're in the wrong class. Oh, come on now. So let me ask you a couple questions here. Factor opinion. What's that? Is it a factor opinion?
What is a sky?
But then this
Okay, all right, ambiguous already, very good. Okay, what about this next one? Can't walk away, okay, cats are smaller than horses.
Which cat?
What?
Yeah, well,
What are you talking about?
Real cats are smaller than real horses. Ask house cat.
Okay.
Okay, all right, finally we can agree on one thing as a class. Okay, what about this? 17 is not an even number. What's an even number?
2 4.
Okay, is that divisible by 2? Okay, so this is a factor opinion. What about this one?
No.
It depends, okay, it depends again, all right.
if you're in space.
Wait, if you're in space, what happens?
You can't drop it. You let it
It
go.
depends, it also depends, if you're in orbit, it's very different than if you're just in space. If I'm just in space, I'm gonna be heading towards whatever's supposed to be very fast. Right? So if I'm in orbit, then I'll be falling. Okay. Guys, beautiful? Okay. That's a fact, that's it, no, all right, cats are better than. That's a fact. No, it's a.
It is.
Okay, 17 is a lucky number. Opinion. All right. Things fall faster when you hope they do.
Like in terms of grades or?
Yes, perhaps. Okay, all right. Okay, so those facts were easily identifiable, maybe, depending on how much argument we had. I didn't prepare this while we're talking. Obviously, I prepared it beforehand. So maybe you learned that the sky is blue. That's just something that you have to believe. These two here are opinions. They're easily identifiable. And then these two, I think, are contentious. Okay? Potential. I'm not saying they're always contentious. Okay. So. Oh gosh, we got farther than I thought we would. That's fine. We're gonna go to the scientific method really quickly. Yes, this one. I think as physicists, you should probably all, if you don't already have this, XKCD, like nerdy little comics, one per day. You'll love it. Okay, so this is me. I pull a lever, I get zapped. And then I wonder if that happens every day. And then on this side, I guess I shouldn't do that. Okay, so it's like the mouse, you get zapped, and then right away, oh shit, I'm not gonna die, man. And then there's a scientist mouse who goes, huh, wonder if that'll happen again. Okay, so we're here hopefully. What is that process? Yeah, it's part of the scientific, right? So it's reproducibility. Will this happen every time? Okay. The hallmark of science is that we can reproduce the results. If it only happens once, it's very tricky to show that it's real. Right? Like, I was once 100 feet tall, but only for a second, and only I was there.
Really?
It's crazy, right? You believe me?
Yeah.
That's supporting me. That's so nice. So if I can never do it again, that's a problem for science, right? You say, hey, listen, that might be your experience. You would have thought that you're 100 feet tall. But I can't agree with you. Because we have a shared experience. Right? We all agree that this is a book. And that it will fall. And that it did fall. We all perceived it as doing that. Right? Okay. So if my clicker's not working, that would be annoying. What would I do? Look at it.
Look at it again.
Look at it again. Okay, it's still not working. I wonder if the battery's dead. And then open it up. Okay, check the battery, maybe replace the battery. Check 4 batteries. Check 4 batteries, look it. Okay, then okay. What did I do then? Right? I did the scientific method. I just did it really quickly. Okay, you've done this a lot in your life. It's not unusual. We're just going to internalize it. Okay, so you have some observation, you ask a question, make a hypothesis about what might be going on, you make a prediction. Okay, so in this case, oh god, that's in totally the wrong spot. So the observation when the clicker wasn't working, ask a question. I wonder if the batteries are dead. The hypothesis is that if I change the batteries, it should work. That's the prediction. I perform the test, it works. Good, batteries are dead. Okay, if I change the batteries, something's wrong with the clicker. Okay, okay. And observations here are the key. So you will get very annoyed if you don't like observations. I'll just have pictures up and I'll ask you to look at them. And I'll say, what's in them? So I want you to practice the process showing me, okay, that's an observation that I have. What can I tell from it? What do I see from it? Okay. That's a long comment, so we're not going to read it. Okay. I think we're going to stop there before we get to Fermi problems because they're fine, but they're not great. They're certainly not something to waste our last 2 minutes on. Are there questions about the class as a whole before we get questions? Okay, so we're going to not do lab this week. We'll have the observing at the observatory on Thursday, as long as it's not windy and there's not clouds. If you ever look up and you can't see the sky, that means that we're not doing observing. Unless you're like really far away.
Will you send out cancellation emails if it's not possible?
I will probably send out an email that it's happening. Right, so you look up and it's, you know, very foggy or it's very rainy or something like that.
How windy is too windy?
What's that?
How windy is too windy?
Windy is a hard one. I'm saying if you look up and it's cloudy.
Yeah.
Yeah. If you look up and it's cloudy, really cloudy here, you can assume it's not possible. Any other questions? Yeah.
Is there a specific time on this?
Yes. About 30 minutes after sunset. That'll be in an email that I'll send out. Has everyone here you looked at the syllabus, you see something called Slack? Sign up for Slack, raise your hand.
The ad code is broken.
Let's replace that one. Okay. Try it again. That still doesn't work. Just send me an email. I will just do your emails by hand. And that's usually the fastest way that I can get in contact with you, or vice versa. Feel free to use it like messaging. Right, if you have something more important, like an email, want to write it all out, that's really fine. You got a list of questions, you just throw them in Slack and I'll answer. Okay.
You want to
Great.
go back or vote?
If you want, just put it back. Save one part of one tree. Yeah, those are sure to do. I'll pick up more today. For you? I mean, yeah. Yeah, these are some other fun books. All right. So Bill Bryson's A Short History of Nearly Everything. Highly recommend. This one is illustrated, so if you want to thumb through that. Oh, this one I wouldn't recommend yet. This one I'm working on. But this one here, the brief history of time, but like black holes, and you want to get to them faster. Where you go. I haven't read this one, but yeah, pretty smart. This one here is about 5 minutes ago died.
At the wrong time. Yeah, I'm not like my friend that part.
So May,
You're in this part?
No.
is that okay?
He's supposed to be the LA.
Yeah, I thought.
What's his name? Okay, we're not gonna do lab today, because, I didn't know that lab was.
Wednesday.
I thought it was Wednesday too.
Right?
No, it starts at 4, but, the lab starts at 5:30.
Did we say we were gonna step up?
No, so I think we wanna meet probably 30 minutes before class. So 3:30, you still have that available, and then, but on days that we have the lecture tutorial, it'll be easier to help you walk.
I'm gonna officially, so I don't have access to the cameras or anything else. Okay, so I don't know if I do that question.
Let me just write your. Yeah, and I'll just send you the. Link to the solar. Yeah, so let's just meet on, Wednesday, so we'll have normal lecture on Thursday. I told them we're gonna have the open house on, Thursday. And so they can come to that, they can do the lab there. And then, next week, next Monday, we'll do, field lab.
So. What's to be on Thursday?
The lab, well, this lab will be the open house. Observatory open house. And I'll run that observatory people unless they wanna come. And then, on Monday, I'll do normal lab.
Yeah, we had class together.
If you look at that.
They're kind of random. So. Just have a look at like, so we'll have our meetings 30 minutes before, no matter what, and then I'll tell you whether or not we're gonna have a lecture tutorial that day. Yeah. Oh, you have the book?
Yeah.
Okay. Oh, shoot, I didn't start